Hello everybody and welcome to your next Allegro 5 tutorial. So in this tutorial we're going to be learning about timers and how that can actually help our movement be less staggered. Now before I start, in the last tutorial I just put up an annotation. I actually accidentally said this just to equals and not equals equals. And that kind of changed the way the code works, because before I could still move and stuff, like when I held down the key. But what it really supposed to happen is that when you press down the key or whatever, it's not supposed to, when you hold it down, it's not supposed to move. You're just supposed to be able to only press it once and it moves one space at a time. So, let's get into this tutorial. So, with timers regulate, they help time the loop so then your game runs efficiently the same speed on every single computer. If you've ever heard about games like that use frames per second basically regulates tells the compiler, the computer, whatever. Tells a game when to update certain elements, when to draw certain elements, etc., etc. So we're going to learn about how to create timers and how to implement them into our program. Okay, so first and foremost, we're going to want to create another boolean called draw. Okay, and we're going to set it to true. And what we're going to want to do, don't worry about that draw right there, we'll focus on that later. What we want to do is that we want to create a timer. So we created a timer by doing Allegro underscore timer and the name of a pointer to the name of the timer, and then we do Allegro create timer. And our timer is our timer is gonna say when to update, right? So if we wanna run our program at say 60 frames per second, we're gonna have to do 1 divided by 60. Because if we want to, 1 is representing the seconds and divided by 60 is going to give us the amount of milliseconds. And whatever that number gives us, when it reaches that certain amount of milliseconds, it will update our code. And then every single loop, it will update it 60 times per second. So for an example, if I get my calculator right here, if I do 1 divided by 60, that gives us 0.016. So every 0.016 milliseconds, our game loop will update. And when you add that up, if you multiply that by 60, it will add up to 60 times per second. Okay? So instead of just doing 60 right there, what we'll do is put a variable called frames per second. And we'll just use a constant int or double, whatever you want to put. Flow FPS is equal to 60. So we'll do it this way just in case anything else relies on the frames per second, that we don't have to change all the values in our program. So we have it set to 60 frames per second, so it's going to update. But our timer, we're going to be using an event with our timer. So just like with every other event, we have to register our event source. So we do al register event source, we put in our queue, and we do al get timer event source. And if you notice, a lot of these, although these commands are really long, you'll notice that a lot of these commands are the same, or they're relatively easy to memorize once you kind of understand what their purpose is. So like when you're like drawing a rectangle or whatever, if you remember that everything starts with al, well, most of the functions start with al underscore, and you know that once you're doing something with a rectangle, you're most likely drawing it to the screen, then you know the function name is probably al rectangle draw or al draw rectangle, and that's a good way to kind of help memorize the method or the functions or whatever, since they can be kind of hard to memorize. But yeah, so we get our timer event source and we put in our timer right there. Okay. So once we do that, what we need to do is that we need to do al start timer, and we put in the name of our timer in here, in the parameters, and we'll start the timer. Now, one thing to note, don't do anything after the timer except for putting the game loop. If you try to initialize any variables or try to do anything after the timer, it might mess up your timer, and you don't want that. If it mess up your timer, it can mess up your game. It could ruin the flow of your game. So anyways, we start the timer, and if we run this program, we'll see a difference. Okay, so off the bat, before when we ran our program, we didn't see our box. Before, the box never showed up, but now it shows up right away. Now, if you notice, our movement is still staggered, right? We still have to keep on pressing to do movement, but we're getting a start. We're getting somewhere. So let us scroll down to see what we can do to. No, actually, let's scroll up, and what we're gonna do is we're gonna create an enum. Okay, so let's make an enum called direction, and then this enum we're gonna have up, down, left, and right. And there's a reason I'm creating an enum now. You might be saying this is why do we need to do all this? But I'm doing this for future tutorials when we learn about sprite sheets and stuff. That's gonna be really significant to us. So what we're gonna have do is have a direction called integer variable called direction, and we're going to set the direction to down. Okay, so what we're going to do is that instead of increasing this by move speed every single time, what we're going to do is that we're going to set direction equal to down, and same for all of these. So to save time, I'm just going to pause it and do it, and then run it when it's done. Okay, so as you see, we have our direction left, right, up, and down. So we registered our timer event, but we haven't done anything with a timer event. So what we're going to do is that we're going to say that if events.type is equal to Allegro event timer. So if our timer ticks, or if it's at 0.016 milliseconds, so if it's time to update our timer, then this is what we're going to do. So we're going to do a switch statement, have our direction in there, have case, and we can switch all these. So now we could copy all this, so copy this statement right here, and post it in there. So if they press the down key, then we're going to change our y plus equals move speed. If they press up, y minus equals move speed. If they press right, x plus equals move speed. And if they press left, x minus equal move speed. So just from that, if you run this program, I just put this as a capital Y, it should be lowercase y. So no movement is occurring. That means I made an error. So let's check what I did wrong. Oh, my bad. What am I doing? I checked for Allegro key down. Sorry, we should be checking for our enum. So if direction equals to up, down, up, left, or right, then this is what we're going to do. So run this one more time. So as you can see, it starts moving down at first because we set our initial direction to down. And when we press a different direction, it continues moving in that direction. So now we got a smooth animation from that. But one problem is that we don't want to just randomly draw. We want to draw 60 times per second. So we only want to draw whenever we update something. Because if we don't we only want to draw during a certain update, because if we haven't updated anything, then what's the point of redrawing something when nothing has changed in our game world, right? So we can easily copy this code and put this code within this timer right here. But once you work with timers, once you work with events, you don't want much things in your event loops, because or in your event statements or whatever, because if you do a lot of stuff with them, it could ruin the flow of the events. So the reason why I told you to create that draw boolean right there is that what we're gonna do is we're gonna set it that if the events dot timer, if it occurs, so if we activate our update timer, then we set draw to true. So if draw is equal to true, then we put all the draw commands in there. So if draw is equal to true, then we draw everything to the screen, and if it's not, then we don't. And then after that, we just set draw equal to false. So we're basically we're saving, since drawing requires a lot from the hardware, right? So instead of putting that in the event a timer and then ruining that type of event or ruining the sequence of the events, we just set draw equals to true, and if it draws true, then we draw everything and we set draw equals to false again. So if we run this program right here, we won't notice really much of a difference, but everything is drawn according to whenever we update something on our screen. So that is it for this tutorial. I hope you enjoyed it. Thanks for watching, and bye.